Hi there, DeepRacer enthusiasts. My name is Don Barber. I'm a Senior Solutions Architect Manager at AWS, but more importantly, I'm a member of the DeepRacer Pit Crew, which means I've had the chance to help thousands of developers get started with reinforcement learning. Today, we're like to welcome you to shift your machine learning model into overdrive with AWS DeepRacer analysis tools. Hopefully, you've had a chance to get started with DeepRacer, had a chance to log into the console, created a vehicle in your garage, trained up a model, and submitted that model to the leaderboard. If you haven't had a chance to do that, I highly recommend you jump over to the AIM 204 course and take that intro course on AWS DeepRacer. And after you've had a little bit of experience, come back here to learn how to take your model into the next level. So, what we'll be going through today is first we're going to go over what's new for AWS DeepRacer in 2021. Very excited about that. Then we're going to be going into some tips and techniques for taking your reward functions to the next level. Then we're going to be going into some how to interpret those training graphs that you see in the console. And then finally, we'll be jumping into some advanced techniques to analyze the training log data and your model itself for additional insights. So first, let's listen to what's coming new to DeepRacer this year.
The AWS DeepRacer League is the world's first global autonomous racing league, where developers of all skill levels can get hands-on with machine learning through a cloud-based 3D racing simulator. This year, AWS DeepRacer introduces the Open and Pro divisions. Anyone can race in the Open division and earn digital rewards, but to score a spot in the Pro, you need to finish one of the monthly virtual races with a time in the top 10%. In both divisions, racers can win monthly prizes, including dozens of vehicle customizations and hundreds of official DeepRacer items. Those who earn a spot in the Pro division can also win DeepRacer Evo cars and a trip to AWS reInvent. Get in the race and start training your DeepRacer model today.
Awesome. I am so looking forward to that, the Open and Pro divisions. And that's really what this presentation is all about, right? Is to get out of that Open division and into that Pro division for prizes and glory, right? So let's just jump right in here. First, let's talk about your reward function. So quick little review of reward function. It is a Python function with a variety of parameters being passed in through that parameters dictionary we see in the first line of the function definition. We'll be reviewing a list of all those parameters on the next slide, but this particular example just uses two of them, which is the width of the track and the distance from the center line of the vehicle. And what it does is it basically just gives a high reward if you are within 25% of the center line of the track. Otherwise, it gives a lower reward, or what we also call a punishment. So if we shift to what is available in your reward function is this list. So you can see, everything there is to know about the car, what the car is doing, and the environment around the car. If you wanted to dive deeper into any one of these, visit that link on the bottom where you could jump to the DeepRacer documentation that could talk about that. It's also really, really important to note that the car is being driven by its neural network, not by your reward function. So the information is coming in from the sensors, being the image from the camera or the image from the LiDAR sensor on top of the vehicle, being passed through the neural network, and using that information, it's making its decision on what action to take. Then your reward function runs and makes a judgment on that, saying that was a good decision or that was a bad decision. And the neural network is going to be able to use that to improve its training over time. And there's a variety of strategies you could use to judge on, is that a good decision or a bad decision? And that's really up to what you are coming up with as a developer using these reward function parameters. So a whole universe of possibilities is available to you there. So I'm going to talk about a couple of those parameters that are often overlooked by developers. And the first one of those is steps. So steps is basically one iteration of that loop. So basically the image is coming in from the camera, passing through the neural network. From there, it's making its decision on what to do, and your reward function is then judging that decision. And then it's happening again and again, about 15 times a second. And each one of those iterations is a step. But what's really, really powerful is when you combine steps with progress. So you can see here on the left, there is a rather straightforward follow the center line type reward function, probably very similar to the one that we looked at a couple slides ago. But by adding, just tweaking the code a little bit to look at progress over steps, we could actually get the vehicle to actually go to the inside of the turn and shave entire seconds off of its course. So really, really powerful, really, really easy, just a nice thing to add on there. I'm going to digress for a second here and actually talk about some techniques for actually evaluating your reward function itself. So let's say you have a reward function that's pretty complex and you're not actually sure it's going to result in the behavior that you want. It might actually make sense to graph that reward function. And you can see here that we're graphing this reward function, which has two input variables, progress and steps, each on individual axes, the y and the x axes. And the output is a color scale, basically dark blue for a low reward and bright yellow for a high reward. And what's going to happen is the neural network is going to learn, try to basically move into those bright yellow areas. It's going to try to localize to those areas of the graph here. In that way, and that's exactly what we want to come out of this, right? We want to have high progress and low steps. And depending on your reward function, it might be rather complex. You might have to go to 3D or 4D graphs or even composite variable graphs. But it's a really, really powerful way that all machine learning experts use in order to really, make powerful reinforcement learning algorithms. Another useful input parameter is waypoints, and lots of times developers dismiss this as being, not elegant or too complex or something like that. But it's actually a really, really powerful way to customize the behavior of your reward function at different areas of the tracks where you're actually seeking different behavior. So, for example, at the bottom of this reInvent 2018 track, we see a straightaway. We want that vehicle to go straight and fast at this point. But as it's going into the curve, we want it to enter that curve from the outside. And as it moves through the curve, once it's in the middle of the curve, be on the inside, and then accelerate out of the curve, lining itself up for the next curve coming up, right? And so we could dive further into that, and we could actually see, hey, leading up to that curve is between waypoints 5 and 9, and we really want to be on the outside of the track there. Conversely, between waypoints 10 and 20, we want to be on the inside of the track. So how do we actually make that behavior sort of distinct in the reward function? We could actually put a little if statement in there. I said, hey, if we're between 5 and 9, then reward if you're on the outside of the track. And using this, we could actually get the behavior we want out of the reward function, and the neural network will learn to actually pursue this behavior. While we're talking about waypoints, it's actually really, really helpful. I want to recommend using some modules available to you in the Python environment of DeepRacer, which is NumPy, SciPy, and Shapely. And for this example, we see it's using the linear ring object class of the Shapely module to load in the waypoints, and with 3 lines of code, able to determine the distance between an object and the center line of the track. Imagine if you were trying to do this yourself by looping over the array, the waypoints array. You'd have to do all kinds of trigonometry and tangent lines and Pythagorean's theorem to sort of come up with that. But speaking of geometry and trigonometry, it's still really, really common that developers need to actually figure out distances between 2 waypoints or 2 points in general. Or the angles between those. So quick little reminder of the math here. To find the distance between 2 points, use Pythagorean's theorem. You can see the formula there. And also, if you're going to find out angles between 2 points, very much use atan2. There is an atan function available, but don't use that. The reason why is because if the target waypoint you're interested in is actually closer to the origin or closer to the 0, 0 point, its x and y deltas will actually be negative. And those 2 negatives will actually cancel out. And atan will actually give you an angle in the completely opposite direction. So every single standard math library has an atan2 function. Very much make use of that, and you'll get the right angle that you need. Also to keep in mind is that atan2 will return the answer in radians. And the degrees heading in the parameter dictionary is in the heading in the parameters dictionary is in degrees. So you need to convert one to the other. That's pretty straightforward. Just multiply by 180 divided by pi. Also keep in mind that that headings parameter goes from positive 180 to negative 180. So if the vehicle is heading directly to the y-axis, or x equals 0, it's going to be going at 180 degrees. And if it makes a slight shift to the left, it's going to look like it might have actually swung 360 degrees to the right instead of actually making that slight shift to the left. So make sure to take that into account when doing your reward function, maybe some modular arithmetic or something like that. So hopefully you got something out of, found something compelling in that section on reward functions. And now we're going to jump into training observation. How do you interpret those training graphs that you see in the console? And it's really important to point out here that there's actually a little bit of art to machine learning here. And I sort of liken it to a brain scientist trying to figure out what's going on inside of a brain by attaching electrodes to the head, right? And it's a little bit like that here. There's definitely going to be some interpretation here. And so what I'm going to be doing is interpreting some of these graphs to give you a sense of how to do that. So quick little tour here. The green line is the reward over time, and the red and blue lines are the percentage completed for evaluation and training jobs, respectively. Those are on separate axes. The reward graph is on the left axis, which is variable. It will actually change depending on the reward values you choose to use in your reward function. Whereas the axes on the right, the percentage completion goes from 0 to 100%. Those are fixed. Every so often, a developer will ask me something like, well, what does it mean when my evaluation completion line goes above my reward line? And it really doesn't mean anything. They are actually separate scales and separate graphs. So just take that into account. But zeroing in on this graph itself, what I see here is it's been about 600 iterations, so not too long, and my evaluation line has just reached 100% a little bit ago. It's still bouncing around a little bit, but it's pretty much there. While my reward lines and my training completion graphs are still trending up. So this is actually a really good graph. It basically just says, hey, we need a little bit more training time on this one, but all systems go. This actually looks exactly like you'd want it to be for this stage in training. So kudos to whoever did this training job. We also get a little bit of a question at this point on why are the training and evaluation lines separate? So I'm going to dive under the hood a little bit here on what's actually going on. So what's happening in DeepRacer is the vehicle, during a training job, the vehicle is exploring its environment. There's actually a little bit of entropy or a little bit of randomness injected in, so it's trying out different things. And entropy is actually super, super important in machine learning. It actually dates back to Alan Turing's seminal paper in 1950 on computing machinery and intelligence. But it's basically exploring the environment, and after it collects enough exploration information, it's going to go off and basically take that batch of data and do a bunch of math and try to figure out, like, how should I update the neural network to reflect the weights and biases to basically get further along the track. But while it's doing that, the 3D environment is freed up. And during that time, the DeepRacer system is going to run an evaluation job where it's going to tell the neural network, just go ahead and run this, do the best job you can. Don't try any experiments, don't try anything new, just do the best job you can with what you've learned so far. And for that reason, that's why we very typically see the evaluation line to be above the training line. And it's actually going to be a little bit closer to what you'll see when you're doing an actual competition run, either in a virtual race or in a in-person event. But still important. But that is why those two graphs are separate. Jumping to the next one. So I see on this one, it's been about 6,000 iterations. This job has been running for quite a long time. But our percentage completion graphs have not, they're still around 15%. And our reward graph is really almost random here, it looks like. So looking at this, I would actually strongly suspect that the reward function is not rewarding on anything that's actually helpful for training, for learning. So I would actually say that, to throw this reward function away and start over, or at least heavily modify it to do something that the neural network can actually use to learn and get better. Overfitting. So this comes up quite a bit, and it's a really important topic in machine learning. So in traditional machine learning, overfitting is when you take a training set and you've trained so much on that training set that if you ask it one of the data points in your training set, it knows the answer exactly. It could tell you spot on. But if you ask it anything else, even something close to the training set, it has no idea. It's going to give something way, way off. And the way we see this in DeepRacer is when a developer overtrains on one specific track. So a good model will actually learn to operate on the features of the road. It's going to basically look at the center line and the side lines, and if it sees, hey, those lines are generally turning to the left, I'm going to turn my wheels to the left and go that way. But what an overtrained model might do is actually ignore the features of the road and actually say, hey, I see this certain shape of grass in the background, or this certain angle of the wall against the floor, or something like that. And in the past, when I've seen that, I need to turn to the left. And the thing is, that works really, really well on that track, but only on that track. If you are going to try to use that model on a different track, or maybe you're going to try to take it to an in-person event where the lighting is slightly different, or the barrier is, you know, 1.5 inches further away, or something like that, the model's not going to know how to operate. It's going to be completely off base, and you're going to see some really, really random behavior. So looking at this graph right here, I could see that it's been training not for so long, about 600 iterations, but it's been at 100% for evaluation for quite some time now, and just got there with training. So I would actually say this is pretty much a fully trained model at this point. I would actually stop training and consider this to be a good model to go. But if you did want to train further, so maybe you were doing something where you were training it to get around the track, and then you wanted to shift training to reward on getting around the track much faster, or something like that, consider switching this to a different track so you don't overtrain on that first track. So let's say you were on the reInvent 2018 track, maybe shift over to the bow tie track or something like that. And that's actually a really, really valid strategy to prevent overtraining, is, you know, an hour on this track, an hour on that track, and an hour on that track. So definitely something to consider there. And then hyperparameters. I want to talk about this for a second. The default hyperparameters in DeepRacer are actually really, really good. The DeepRacer team has spent a lot of time sort of thinking about those and making the defaults, you know, good for the vast majority of use cases. So every so often we'll see developers sort of over-index, you know, focusing on adjusting hyperparameters when it's really not needed. They should be spending the time focusing on your reward function. That's really where, you know, the bang for the buck is going to be. But every so often, it does happen where the hyperparameters need to be adjusted. So looking at this graph here, we can see it's actually doing a pretty good job in evaluation, but the reward line and the training completion lines are sort of ricocheting back and forth. And what that might suggest is the actual learning factor might be too high. And that's something where as your training job runs and it actually adjusts the weights and biases, it actually adjusts the amounts of those by the learning factor. And what it might be doing is actually going over optimal, and then the next training run actually going under optimal. And it's basically making too big of a jump over optimal, and it can never actually get close to optimal. So if you're seeing something like this, maybe consider pausing training and restarting it with a lower learning factor, maybe a half of the value or the 1/10 of the value, and see if that actually lets you get closer to optimal there. But generally the hyperparameters are pretty good on default, and it's not something to focus on. So hopefully you have a bit of a sense of how to interpret those training graphs now, and a little bit less lost when looking at them in the console. But one of those training graphs don't have what the information that you're actually interested in. So they had the percentage completion around the track, but they didn't say anything about speed, right? And if you have two models and they both get all the way around the track, but one of them goes faster than the other one, well, that one's going to win every time, right? So in order to really tease out that extra bit of information, you really have to go into the data yourself. And so for that reason, that's why the DeepRacer makes the training log data available, and you could download it and process it and analyze it however you want. So here is an example log entry. A typical log would have thousands of lines like these, one for every episode and step. An episode is basically a lap. It's from the time you start the lap until you complete the lap, or go off the lap and end that episode. And then a step, remember, is the information coming in from the sensors, passing through the neural network, it making a decision, and your reward function judging that decision. But in this particular one, episode 619 and step 44, you could see the car was at x coordinate 2.95 and y coordinate 1.09, plus a variety of other information available, such as the speed and heading and what the reward function actually returned. Now, you could take all this data and analyze it, and what's really, really common is for developers to analyze those in a Jupyter notebook. There is a sample notebook to do exactly that, that the DeepRacer team has published at this URL. What I did is I cloned this notebook into a SageMaker notebook and basically trained up a DeepRacer job on the reInvent 2019 Championship Cup track. And then analyzed it using that notebook. So I'll show you a couple examples from there. The first thing that we see in the log and analysis notebook is a way to visualize the track and waypoints. So you might recall from a couple slides ago when we talked about how using waypoint math and using the waypoints is a really powerful way of tweaking your reward function. And this is a good way of knowing exactly where those waypoints are. So we can see this track has waypoint 0 through 153, and that's rather uniformly distributed. And that's not true of all the tracks. So it's definitely worthwhile taking a look and seeing exactly the track that you're operating on and what its waypoints look like. And then, of course, you could graph the data however you want. In this particular graph, we could see in the upper left, that is the actual rewards over time. And that is the same as the green graph in the console. Point out, there are literally thousands of entries in those log files, so the log analysis notebook does group them into batches of 20, just to make it a little bit easier to visualize, and that is configurable. So we see the average reward going over time, much as we'd expect. But we also see in this middle graph is the deviation of that reward going up over time, which means even though our average is going up, the distance, the separation between our good runs and our bad runs is also going up. And we can see that even more clearly on the scatter plot on the bottom, where we have definitely more good runs, but we still have a lot of bad runs. And so looking at this, I would strongly suggest training this one even longer, because just to get some more consistency out of this. Otherwise, if I was to take this to a competition, some of the runs would be really good, but some of them would be really, really bad, right? And I want more consistency out of my models before I really subject them to real-world racing conditions. So another thing is to analyze the reward distribution for your reward function. You can just sort of see a heat map of where on the track the neural network is being rewarded. And you can see here that the bright spots are really along the center line, but maybe we don't want them to be along the center line. Maybe we want the vehicle to be rewarded for cutting to the inside of turns or something like that. And that's a perfect area where we could go into a reward function and actually say, okay, between this waypoint and that waypoint, I want you to behave a little bit differently. I'm only going to reward if you're on the outside of the track, or something like that. But one thing to point out is that this particular graph is only that the vehicle is being rewarded for something. You don't actually know what it's being rewarded for. And for that, you need to dive even further into the data. And one of the ways to do that is actually histogram for each action distribution. So you may remember from the vehicle garage that each vehicle has a number of actions it could choose from. This specific, and there's a graph like this for every single one of those actions in your action space. This particular one is for steering of 0 and speed of 0.33 meters per second. You could see that in the upper right of the image. And this is basically every spot along the track where that action was rewarded. What's really, really interesting is if you look in the upper right of the map itself, you can see a very sharp turn between waypoints 82 and 93. And it's getting rewarded for going straight on a very sharp left turn. So that's really interesting. And maybe I want to go in there to my reward function and actually make a specific if statement to not do that. Otherwise, this might be ending up in some behavior that I don't want. But conversely, let's look at the exact same training job, but a different action. This particular action is a 30-degree right turn at 0.33 meters per second. And you can see that there's absolutely no reward given this entire time. The reason for that is because my reward function actually punishes for any turn over 15 degrees. Therefore, it's never going to choose to do that. But what this also shows is I've wasted an entire action space on something. First off, I probably don't need to do a right turn of 30 degrees anywhere on this track. It really doesn't have any sharp right turns. And furthermore, I actually punish for that. So this is showing the discrepancy between the track, my action space, and my rewards. And I'm basically wasting a lot of training math on nodes that I'm never going to use. So it can help you get more efficient by diving into some of this data. And then this is one of my favorite parts of the log analysis notebook, is there are over 900 images available that you could pass into your model and actually see exactly what your model is actually focusing on and making its decisions on. So a couple examples here. We could see on the left, the vehicle is about to pass over and the outer line that is shifting to the left. So, but the neural network is looking right at that line. It knows it's there. It's going to make its decision based on that line. And hopefully that decision is sharp turn to the left to not go over that line. But it's sort of exactly what we want it to be looking at in an image like this. Whereas in that middle, that's a little bit more questionable. Nothing really alarming here or anything like that, but there's not a lot of clarity on what it's looking at, or if it's actually really looking at anything in particular. So if I was to see this, I would actually say, maybe this one needs some more training just to be a little bit more decisive in this situation. But then the last one on the right here, this one's actually rather alarming. It is looking at the center line and the outer line, but it has a lot more focus on the grassy area and that angle between the wall and the floor, which makes me think that this might actually be overtrained. So because of that, I would actually consider training this further on a different track just to help it unlearn that behavior. So hopefully you found that compelling. Really, suggest you take advantage of some of the tips and techniques we went over today. Check out these URLs. There is another link to the training notebook that we went over earlier. And make sure to check out our training certification courses as well. Lots of things available there. And developers, start your engines. Thanks so much for spending time with me today. My name is Don Barber. Thanks for being here. And make sure to fill out the survey, please.